if I had just written a bash script to run this make file in order, it would have taken me 90 seconds. And so I was like, not everything is a good task for an agent. And if you know the order stuff is going to happen in, then you probably don't need it. Like, you probably don't need an agent if you know the workflow order. And that's going to take me to like what we're going to talk about today on the show is like, how do I apply these 12-factor agent principles to coding SDK?
That's literally the only two things you can do. Everything else doesn't matter here. For anyone that tries to sell you any product or anything, like the only two things you can do is have fewer steps or have a more accurate step selection system. Everything else is totally garbage in terms of making your system better.
One of the things I do as an engineering leader is we're using the AMP agent and Claude Code. And the benefit of AMP is I go and I read and review their threads. And I use that as the primary coaching tool to help them climb the curve on agentic AI engineering and agentic coding.
All right, cool. So welcome to the AI That Works show, where we talk about, you guessed it, AI that actually works. We do a lot of live coding, do a lot of whiteboarding. The goal is that you walk away with real applicable learnings and things that you can use to build better AI apps that are more reliable, more performant, maybe better, faster, cheaper. I'm Dex. I'm the founder of a company called Human Layer. We help people use coding agents to solve hard problems in complex code bases. I am joined by Vaibhav.
I'm Vaibhav. I make BAML. We make AI systems more reliable by building a programming language that does a lot of the off-lifting for you, or on the heavy side.
Amazing. And today we are going to talk about a really fun topic that's going to kind of like thread together some of the some of my favorite episodes we've done in the past, which are talking about concepts like 12-factor agents and also the ideas behind like doing context engineering with coding agents directly. And we're going to give you a little bit of preview of kind of how we're thinking about better workflows and how to get even more out of research plan implement with structured workflows and kind of some of the problems we had. So, and then in, was it 2 weeks, we're going to do a live coding where we're actually going to just like spend a couple hours building features on BAML and kind of show some of the stuff in practice. And I think we got Mike here. He hit me up this morning. He's like, oh, I built this project. I'm like, wait, this is exactly what we're talking about on the podcast today. Like, will you come show it off? So I'm excited to see that as well.
That'll be perfect.
Incredible. So let's talk about...
Do you want me to screen share, Dexter? I'll screen share the whiteboard.
I got it.
Okay.
Okay. So we talked about, there's some concepts here. And so I'm going to go into AI That Works. Not this episode. We talked in this episode of 12-factor agents, basically the ideas behind... Oh, there's no whiteboards on that one. All right. You can go find the talk on 12-factor agents. It's everywhere. But we talked in 8.5 about advanced context engineering for coding agents. And we kind of talked about like understanding how a context window works when you're working with coding agents and like when to compact into a smaller file and like how all this works and thinking about impact and like research and then planning and then implementing. And then the main idea behind 12-factor agents was you would basically have this like agent loop that would, determine a next, like it would like call a tool and you would have a ton of different tools you could call. And then this thing would just like loop forever until you hit your exit condition, right? Does it make sense? Vaibhav, following?
Mm-hmm.
This is your like determine next. We called this like determine next step.
Yeah, you're basically asking the model, what should I do next? You can think of like a switch statement.
Yep. And then over time, you're like building up your context window with like, okay, user message, tool, response, etc., until the model says like, okay, now we're actually done. And the like kind of like idea from 12-factor agents is like, this was cool because it let you take a like what used to be a deterministic workflow of like, okay, we do this and then we do this and then maybe we do this or we do this. And this is how we used to write programs, right? It was like deterministic code. There was maybe some looping and then this would take you back to here until it was done. And then eventually you would get to some end state, right? And the idea with like 12-factor agents was you could just take all of these like potential, I guess they're not nodes, but they're edges. Like what are the state transitions available to the model? And you could just say like, cool, here's all the tools you have. Here's a thing. Here's like a problem or like an event or a question or whatever it is. And the model would be like, okay, I have to call this tool. Now we have to call this tool. Now we have to call this one again. Now we have to call this tool. Now we have to call this one again. And then eventually it would like make its way to the exit without you having to hard code all this logic. And so this stuff would be kind of like, it was the promise of it was like, okay, you write less code, you just give the model a prompt and a bag of tools. And the issue we found was like, as this context gets really, really long, like more than, n tokens, models can get, especially last year in like mid-April, models could get really confused and they wouldn't do a very good job. And so we kind of reframed how we thought about this from like tools in a loop to like, you have like a set of like prompts and maybe you have like small sets where you're like classifying between nodes. And then this would go through some deterministic code, right? And this would have a step and this would have a step. And then you would have over here, you would have like another generative AI step where maybe this one is like a little like tools in a loop where it might go like,
Yeah, the idea.
it might
the
do
idea,
something
I think,
and loop back.
I think the idea
or it
you're
might
describing,
immediately exit.
Dexter, the idea that you're trying to describe here is that models give us a way to loosely have state transitions that are undefined. But the more state transitions that you have that are undefined, and the less concrete your system is, clearly the more unreliable it becomes, especially for longer running tasks. Because longer running tasks require more state. So if you have a probability of, let's say, one thing going wrong out of every 100, if you only have one step, it'll work 99% of the time. If you have 50 steps, I think that's going to be like that's quickly going to drop like a 60% accuracy, even if it picks the right step one every 100 times. It picks the right step every.
Do you have that graph handy of the like fall off of like if you're like 98% like
I do.
accurate?
I'll snap that in there really fast.
Yeah.
What's somewhere here?
I'm gonna find LangChain had this graph. I think it was like cognitive architectures. And they had this was from a while ago, but I think this is still relevant, which is like code versus one LLM call versus chaining LLM calls versus like a router that decides like which step goes next versus like fully autonomous that like decides which steps are available to take. Oh, weird. They had this like autonomy versus determinism workflows. Let me see if I can find this. They had this, well, I'll just draw it. They had this chart that I think was really, so this is the chart that I was talking about, right? Where it's like, depending on your accuracy, even if you're 99% accurate, if you're doing 20 steps, that potential to veer off course compounds very quickly, right?
Yeah. Like you're just not going to have good results if you're doing it right. So like,
and so you have two levers.
Go ahead.
I was gonna say, you have two levers. You can make this gap smaller. You can make the like accuracy of the tool calling better, or you can make this context window smaller, and then it like the poor accuracy matters less.
Yeah, that's literally the only two things you can do. Everything else doesn't matter here. For anyone that tries to sell you any product or anything, like the only two things you can do is have fewer steps or have a more accurate step selection system. Everything else is totally garbage in terms of making your system better.
And so, it's like more deterministic. There's like two curves here, right? Is like, as you're more deterministic, you're like, what is this? Like uncertainty.
Yeah. It's like variance.
Yeah. Variance. But also like the variance goes up, but also like the other thing that increases here, I really wish I could remember this chart because it was nice, but it was, and the other part was like, it's also like your robustness goes up, right? If this workflow,
you mean the other way around? Robustness goes down as you become less.
Well, so so the thing I want to talk about is like if you have this full deterministic workflow and one of these fails in a way that you don't predict, then you are screwed. But if you have a thing where like on an error we loop back to an LLM step over here, then the LLM can try to wiggle its way out of the error in a way that you might not have thought of. Yes. So there's like this
this
is interesting trade-off that I think is really important to think about in AI engineering.
I think what you're trying to talk about is like variance of inputs also goes up. Like the variance of inputs of what you can handle also goes up. But I think the thing that I was talking about is the thing that ends up going down is actually, let me put this over here. The thing that ends up going down is like the consistency.
Yes, I like that. That's great. Nice. Cool. So anyways, there's this thing in AI engineering, which is like, where do you want your application to be on this spectrum, right? You get to decide for a specific piece of work and for the entire pipeline, like, how do you want to build this? And the lesson from like 12-factor agents was this idea of like, let me see if I can find the slides here.
People asked, is Claude Code still the main workhorse for you too? For me personally, I actually rotate still between Claude Code and Cursor. And actually, funnily enough, I use anti-gravity sometimes.
What did you think?
I honestly can't tell the difference between the models most of the time. If I'm completely honest, I feel like I think I got my Cursor summary, and the funniest thing was like, Cursor was just like, you can just see my pattern. I usually just pick whatever model is the most recently picked, and I just use it. Yeah. And that's it. And at some point, I change the model, and then I switch and stay over. And that's all I do.
Yeah. It's getting more of like, what can you build on top of the model to customize it for your workflow and your team and your code base, and who's got the best UX, and like, it's how the end of the day is like, what are the outcomes? And I think as far as like the driver model, all of the labs building models are getting pretty good at this, like RL the model on the harness. And that was an innovation last year that like just made these things like good enough to be actually usable. I guess the story I was going to tell was this idea. I don't actually have a slide for it. I think it's just a story that I was telling. So I'll just draw it out. But basically, is this going to let me share? I had built this like project where it was like, okay, I have this make file. You know, do you ever use a make file? You're a C++ guy, right?
Yeah, I hate make files, but I accept them.
Yeah. Are you a just file guy?
I honestly prefer now cargo.lock and cargo.toml. Cargo is the way to go. People should never use make.
Okay. You heard it here first. Hot takes. So I had this make file, and then I like built this tiny little agent, and it had two tools, and it could do like run. It was like read make tasks and like run make tasks, and it would just run the thing and give it the output, right? And I said, hey, go build the project. And it messed it up. It got the wrong things. Like there was like a Docker thing that needed to happen. It just like couldn't really understand how to build the project. And this was also like, I think this was like Sonnet 3 or something. This was like before the really good Sonnet 3.5 model came out. And so like I started adding more directions, like you have to build before you compile. And then it like got parts of it right. And then I just kept adding more and more instructions here. And this is what I call like control flow via prompt.
Yep.
And the lesson after the 2 hours of like getting it working was like, I had literally just run these 7 tools in order and like go from there. And if one of them failed, it couldn't really figure out its way out of it. And so like the lesson there was like, okay, if I had just written a bash script to run this make file in order, it would have taken me 90 seconds. And so I was like, not everything is a good task for an agent. And if you know the order stuff is going to happen in, then you probably don't need it. Like you probably don't need an agent if you know the workflow order. And that's going to take me to like what we're going to talk about today on the show is like, how do I apply these 12-factor agent principles to coding SDKs? We have source prompt. So this is a prompt that I'm sure many of you are very familiar with. This is the like OG create plan prompt from Human Layer. And this is instructions to take some research and turn it into, so we have like, a research document and then like a task, like a ticket or a PRD or something, like a description of what we want to build. And we take these and we give them to Claude and we get out a like plan.md, right? You've used this, Vaibhav? I think we've used this on stream before.
I have used this on stream. We have seen this over here.
So it's got a lot of steps. So it's got like outer steps and inner steps. Step 1, step 2, step 3, step 4, step 5. This is just to get the setup and tell it like, here's what we couldn't figure out yet. And then it's like go research the code base and spawn parallel subtasks. And then it's, structure out the plan, work back and forth with the user to ask. There's like a design question step of like, okay, here's where we are, and here's like the open questions and things like this. And then we actually go write this plan file. And so inside of this like single prompt with tons of guidance and instructions, there's actually like embedded inside of it is a workflow. So like create plan actually has like several nodes in the workflow that are like research current understanding, do additional code base research. And then it's like, design discussion with the user. That's, I'll just take a screenshot of this and drop it in. So yeah, here's our design options.
And really the key idea here is like, look, any process that people embed anywhere in the world often is described as a workflow. Sometimes a workflow is well described and there's a really well understood control flow in that workflow. And sometimes a workflow is like, it's just hand wavy instructions that are approximately what you should do, and you need to use your best judgment along the way to adjust things as you go.
Yep.
And I think what you're saying here is like, this sounds to be like a little hybrid of both of these.
Yeah, I mean the idea was it has a lot of steps, and so it's like there's these things and there's things that need to go back and forth, and I'm gonna go kick off a couple of these in a sec. So if I go to let's make a new task here, it works. Human layer. So this is going to be. Okay, that's a bug. If I pop in here and set a new session, I just say create plan. We're gonna update the MCP server to use streamable MCP on the HLD service. This is going to start going through the workflow. I'm also going to launch another one of these. This is like a thing that we found was like, really, when we work with customers and people were kind of like rushing through this, there was often like the model would basically skip steps. There's like a ton of instructions in here, and it wouldn't always do these two phases, which are the parts that actually make the plan really good. If you just tell it, here's what we want to do, and it like slops out a file, you're probably not getting much better results than if you were like, Claude, go write this code. And so like the thing that made planning really powerful were these things that happened earlier in the conversation state, because like the way this context window looks is you have your system message, you have your user message, and the system has all the like prompts and tools and MCPs and all this crap. And then you would drop in your user message, and then it would like go do some tool calling that was like pretty sparse, right? It would do some research and things like this. And then the idea was the assistant would ask you like design questions, right? And then you would have a user message, and then it would ask, you would go back and forth here, and then you would like say, okay, that's good. And then it would tell you like, structure outline or the phases, right? What order do you want to do these things in to make it like testable and incremental and like easy to catch it before it's off track? And so we would do all this stuff, and then finally at the very end we would write the plan. And this was like 10% of the context window, because these end up being like 1,000 lines. It could be like 5 to 10% of the context window. And then if you wanted to like iterate after this and give it feedback, you're already like close to or deep in you're like close to or deep in the like smart dumb line. You're like your performance is degrading because you're so deep in the context window. But also like the model is now, most of the context window and most of the attention is on the decisions the model made to write the like to like about how we're approaching this. And so what we found was like often you would get, you would send your user message with the prompt, and the model would go and it would do some research, and then it would go straight to writing the plan. And so you're already very much like trajectory. Like most of your context window is like, we're going in this direction. This is what we're doing. We're going in this direction. This is what we're doing. And so if you wanted to give feedback here, it was like much lower leverage as far as like being able to adjust the plan mid-flight versus these like short back and forths, which are still very early in the context window and are like very context efficient way to deviate from what the model wanted to do before it goes and dumps out all these tokens. Does that make sense?
The other thing that actually ends up being true in exactly what you're saying is that let's say you did provide feedback in the second latter half over here.
Yeah.
What ends up happening is when you provide feedback here and it rewrites the same plan, it takes your feedback and then adjusts it for like parts of it.
Yeah.
And it might even catch like some other, it might apply the feedback there, it might apply the feedback there. But almost definitely what I find is like, it would totally forget the feedback that it needs to apply over here and the feedback that it needs to apply over here. So it actually became a lot more inconsistent as it did as well, because like editing with consistency is a much harder task than creating with consistency.
Right.
Right.
Yeah, because you're changing trajectory. This is the same thing of like re-steering the model in the middle of a workflow, right? It's like, okay, it was going this direction. And now you have like noisy instructions where it's like, oh, the user said this and that meant this. So I did this. And then the user said this. So I have to like ignore all the things that came before it. And it's just like more, I hate
very
to
hard.
describe it as like mental load on the model, but you just want to reduce the number of things it has to think about. And
I've actually personally,
really sorry, say what?
I found personally the same thing. What I often found is like if the model, so when you go back and share the diagram again, what I found is like there's actually a trade-off here in both these sides. On the left side, the trade-off is it's a little bit slower because it's more interactive, but I usually get a much better result. On the right side, it's much faster. It's literally like 10 to 15 minutes faster to produce the result. But the difference is it's often right the first time around on the left side. On the right side, it's just not right all the time. But what I've found is what I will often do is I'll actually kick off two different tasks. Or I'll just do the right task first. And if it's like 95% correct, I let it go. And if it's not, I actually delete it and then restart from left and then force it to go down the left path manually. Exactly.
Make it do the discussion.
Because it's exactly what you're talking about earlier in that diagram of like control flow versus variability. Like, yes, I got a high variance outcome that handled a really wide output. But if it works, great. I'm super happy to have it. And if it doesn't, instead of trying to steer that correctly, just go back and start from zero and build the deterministic workflow that I actually need.
Yep. And so like we can do this with prompting, and like a thing that people have found works and that we've like recommended to a ton of folks is like, you can look in this one, and this one literally just, okay, so this one did ask questions because it wasn't very clear. But if you give it a research doc and like a ticket, it will sometimes just blast through and skip those steps and just write the plan. I don't have a perfect demo of that, but I'm sure y'all have seen that. Believe me, it happens a lot. And so the challenge that we had with that was like, okay, there's this doc that Kyle wrote a really good blog post on like writing a good ClotMD, and he included this study, which is like, you know, how many instructions can you give a model before it starts to lose track? And so like frontier thinking LLMs can follow about 150 to 200. This was like 6 or 7 months ago, so it's probably higher. But at the end of the day, like if you went through this prompt and counted the instructions, there's probably over 100 instructions in this. And some of them are like repeating the same thing over. But it's like every time you put in all caps, like you must, important, critical, never, like the model can only attend to so many instructions at a time. And so what we ended up doing in some experiments in the code we'll walk through today is basically like breaking this up into separate workflows and then using structured outputs to like define those workflows. And so we talked about micro agents and 12-factor agents, but basically what we have is we have like, you know, user ticket or like query. And we would pull in like a research doc as well, usually. This whole workflow can be broken down, but we're just going to focus on planning here. And we put it into a like agent that is just the design phase, right? And so this thing is basically like goes and calls tools, and then the final answer is like a structured object.
That's the actual design.
That is it's the actual design. So it has like current state, like is like a string array, desired end state, string array, and then it has like open questions. And this is like an array of objects that is like, title, question, and then like options that it may want to suggest. So like option A is like A, do XYZ.
Sure.
B,
It's like
do
use
ABC.
MCP and don't use MCP.
Yeah, exactly.
There's only one right answer.
Yeah.
But yes.
Okay. All right. And then maybe a recommendation also is like recommendation, like use option A because it's good for these, right? And then you would have like a list of these questions. And so what's cool here is that like you can still take all this data and format it for the user. But you can also feed this into your deterministic code, and you can say like, and I think what we did also was like a like resolved open question so that it knew it could like put the information somewhere. And this would just be like like what are the decisions we've already made? And so every turn of the loop, this thing has an inner loop and an outer loop, right? And so in the inner loop, it's the standard like Claude code, read, bash, edit.
Yep. It's like the Claude code loop.
Yep. And so this will loop for a while and do all the things the Claude code can do. And then at a certain point, the assistant outputs its final answer. And then you have an outer harness, which is like, okay, cool, like all questions answered. And if so, we move into a totally different prompt that is constructed for the structure phase. And it has different instructions. And it's basically like feeding slices of this prompt into the model incrementally throughout the workflow. And so this looks exactly the same. I think this one's structured output was like, instead of open questions, we kept this stuff at the top because we want to keep feeding that same information in, but we would have like the resolved questions, and then we would basically feed in the all questions answered, and then we would take the ticket, the research, and the like structured object from the design discussion. And then this thing outputs like a list of phases, right?
Yeah. And I guess a key thing that you're trying to say here is like, look, sometimes it does make sense to have super high variance, and that is great. But the problem is the more often you do a task, in this case, RPI, research plan implements to render code, the more useful it is to codify something more regularly, because then you can have an expectation of how. I find that so many people go down this route when building anything with AI. You build something and initially you start off saying, you know what, we're gonna completely vibe everything. We're gonna use AI for every decision point everywhere. Because if you go back to that chart that we drew earlier, the XY chart.
Yeah, because you don't know what the space of inputs are, so you want to be able to handle a higher variance of inputs.
And then what ends up happening is you want to bias and every single person that does AI always does this. Like you start off over here and you're like, okay, well, I clearly want to bias. I want to bias for this direction in the beginning because I just need it to work. And when people try my thing, it needs to work all the time. And then you're like, okay, people try it now for truly a large variance of inputs that you never predicted for. And then you're like, okay, well, what I really want is for this large class of inputs, I want it to work with really high certainty. And I want a lot more consistency. Yeah, so then you quickly are like, okay, well, I'm going to lose 20% variance, and instead, I'm just going to move my system over. Oh, why is it so big? I don't know how to fix this. We're going to change this because I cannot possibly. You want to lose a little bit of variance, and you kind of move yourself over this way, just because what you really want is consistency. And then you're like, hey, turns out I want consistency and high variance. So then what you end up doing is you write way more layers, like what you did, is you have loops within loops within loops that kind of compose well together. And that composition is what moves it up on the stack. So you're both able to increase the consistency and the variance by having kind of loops composing within loops. And the trick is like, this is basically just software engineering. You're basically just saying like, I'm going to add a little bit more rigor into my system and like battle test it a lot more. and I'm gonna apply constraints in the least possible, in the most critical joints possible. And now all of a sudden, I have built a system and not just a prompt, and therefore it works way better. But it's often,
and so eventually you end up here where you're more consistent, but you're also can like tolerate a high like variance of outcomes.
It's probably not as variant friendly as the one all the way on the right. But the win in consistency is still well worth it, because if you have a large number of people doing a similar enough task, consistency is actually way more variable, way more useful than variance.
And so this is actually the thing that you talked about this too for classifiers, right? You have a classifier that is like a really small, tiny ML model that can classify out of 1,000, the 1,000 most common categories. It can like run on a CPU and do that. And then the 1,001th category is other. And if it goes to other, then we send it to an expensive LLM. And so you have both consistency, speed, performance on the parts that like are going to happen common, and then you have an escape hatch where you can handle like less common cases.
Exactly. That's literally the route I see every single AI system working at every single one of the time. Someone asked this really good question of like, hey, if I add things like judges or something else that make individual steps better, can I suddenly increase the accuracy of every single system? If you go back to the thing that you were describing down below, Dexter, in the new coding workflow that you had, like the structured output, I think a lot of people are like, oh, well, I think the next intuitive question to ask is exactly what that person asked, which is, hey, can I add a judge here that kind of builds a judge system here to see if this is good or bad, and then makes this work? And I think this ties back into kind of like what we've talked about in the past about latency and consistency and user expectations. You can always add a judge here, and like technically maybe it will get better. And the judge doesn't have to be an LLM. It could be a human. It could be a manual eval. We've talked about so many different kinds of evals in the past. But the problem is,
this doesn't have to be structured. This could be human says yes, ready to proceed versus like no, let's keep working kind of thing. It doesn't have to be AI generated at all. But
the trade-off here is like whatever you do here, it really is about having a process-based checkpoint to actually go do this. If you think about like code reviews, why do we have code reviews? Because we don't want people to manually push the main and break main. We want to have a manual process that artificially slows down the system of submitting code, because we want to make sure that the entropy in the code base is manageable and well understood. In a coding agent workflow, what that person asked about a judge workflow and what Dexter is doing here is he's reducing entropy in the downstream layers by basically validating and having some level of consensus built at some checkpoints. Now, what's really interesting is, and I want your thoughts on this, Dexter. What you could really do is you could kick off this process, but then while this is running, you could kick off some background process, which is a very expensive agentic loop, who's actually evaluating this in the background.
The entire conversation.
Well, maybe just even the design phase step. And then if it finds some weird thing that you haven't thought of, then it notifies you in this phase of like, hey, it does a pop-up and then says, hey, I found something. Is this correct? Do you want to add this to your design decision, or do you want to restart with this context in mind? And I think
do you want to roll back to the design phase?
Or just append this one information into your current structure phase, or just say it's okay. And what's really interesting about this kind of thing is this is kind of, I think, the true benefit of like really interesting UX that you can do with agentic workflows, which is you can let the user go down the golden path, but then be double checking on their behalf with like just a background script that's doing some really interesting behavior.
Yeah, you could even kick this off. One of the things that I am like we're working on is like the research process is a little slow. This thing does its own research. Like, what if we just jump straight into the design discussion and then had the research happen in the background? And as you're talking, you just inject messages into one of these conversations of like, oh, I found a new insight, or like I found a new pattern to follow or something. Like, do you want to pull this into the conversation? And that's where the UX comes in, and like finding the right balance of like, how do you get people really, really good results? Because at the end of the day, is like, I want to ship some code in a complex code base. And so everything you can do, there's so much like out of the box. I hadn't thought about this, but I love this of like just doing constant research in the background while everything else is running.
Yeah, and a lot of people, I think of coding agents as different than regular agents, but they're not. The principles that we talk about everywhere apply every single place. Like if I'm building an agentic workflow for my application of any kind,
Yep.
I almost always would recommend someone that's doing a mission critical, heavily human in the loop workflow to build background agent like that, because that's the only way to give the user the balance of speed along with consistency, because it's fast because you're going down the goal. You're assuming correctness as they move forward, but it's correct because it's pinging you proactively in the background and validating the assumptions kind of more thoroughly as it needs to.
All right, I have some homework. You want to look at some code?
Let's do it.
All right, sick. So we have a couple basic little scripts here. So we can do bun run. So we have some very simple ones. I think there was a bun run source chat. So this is just a really simple hello world of the Claude agent SDK. And so this is just like code that we wrapped around the SDK that just like takes the user message and like, tell me what's in the README, you know? And so this is Claude code under the hood. We're just wrapped the agent SDK with a non-TUI UI. It's just printing messages as we go. Okay, so it's going to try to read the README. It doesn't exist. So this is a really basic one. What we've built on top of this is basically something called structured planning. So this is those like 3 steps of the planning workflow with like deterministic schemas for each one. So like step 1, design, we have summary, and then we have open design questions. And then we run through the conversation. I'll run this in a sec. And then we have the structure outline phase. So it's like let me go find the actual workflow here. So we do design discussion, and then we pass in the questions to the structure outline. I think this should exit when all the questions are answered. Let's see. So we print them out, and then we might have to vibe some changes into this. I was doing this last night; it was working, so I might be looking at the wrong one. But let's run this, and I'll show you. Yes, this one. So here's our structured planning demo. So this is going to ask me for design questions.
Can you press hide at the very bottom of your screen?
Oh, yeah.
Thank you.
We'll make this a little bit bigger. I want to write a banger README for this repo. And these are really smaller like prompts. Is like research the code base, then ask questions about how the user wants to implement this. When all the design questions are answered, set open design questions to an empty array. And so the model is using structured output here. And we ask it in the actual query. Yeah, here we go. So we use the message generator, and then we tell it, hey, the output JSON is this schema here that we have set up for step 1. And so this is going to go do some research and go find the thing. And then when it's done, it should auto advance us basically to the next step of the workflow. I got to go find, where do we return? Yeah, so we just return the output. While this is running, so it's like, okay, response, answer questions. Oh, it's using the ask user question tool. It's not supposed to do that. Alpha software, guys. I think Opus was extra smart last night.
It's probably it. Yeah.
Update structured planning to output only advance if no open questions. So this is the idea, though, is you can stitch these things together with structured outputs. And then there's other fun things you can do with this. So like here we're using the Claude SDK's built-in structured output tooling. So we take the schema, we pass it into the SDK, we say, here's the output format that we want. But we can also do this with BAML. So here's like another one I'll kick off, which is like we don't give it a structured output, but we just wait till the end, and then we run a BAML function that is like parse and structure the design discussion into an object. And so you don't have to use the built-in SOD schema stuff. You can also use BAML. So this is like, again, we just have design output. parse design discussion, like turn it into structured JSON, and then we just use
So the idea is
schema
you're doing
as the
more like
prompting.
this is more like a reflection based system where like the prompt is very flowy, and then you're basically producing structured output at the very end of the system rather than doing it along the way.
Yeah. Okay, so this one finished, and so it did output, here's the summary, and then here's the open questions, and then we actually take those structured open questions and we ask it, the user can't exit. The only exit condition should be if the array is empty. So this is going to keep me in the design phase, and then the idea is like you can do some like deterministic code to just say, oh, there's no more open questions. Let's move to the next phase. And you can wrap this with the BAML thing too, right? You could say like,
And then what's a trade-off of doing this? Like what am I losing when I do this?
What you're losing is you lose a little bit of fluidity. Okay, so it's now it's no open design questions, so it's proceeded to the structure outline.
Like why should I as a developer prefer doing this over using Claude Code?
So this is Claude Code under the hood. Yeah, this one is using like it's approved, ship it. So we have this user approved outline false. So the idea here is like we built a create plan prompt and we built it into a product and we gave it to a bunch of people and we found that they couldn't get good results consistently because the model would not actually reliably follow all the instructions in this prompt. And so the reason to use Claude Code with this basically is like because you still get a good coding agent. You're just like giving it smaller bits of work, and you, the human, are kind of defining the workflow across. And so, like, you're forcing the compaction workflows in between.
Yeah, the idea really is just like being very deliberate about when you're exiting a Claude Code context.
And basically, the frequent intentional compaction, it used to be a lot on the user to make decisions about like, okay, I have enough here that is compacted into a file or something. I can go start a new conversation for the next part of the workflow versus like that requires your users to be experts in the workflow, whether it's legal or coding or whatever it is. But in this way, you can kind of like give them the workflow and guide them through it instead of...
Yeah, it's like a more opinionated coding agent. A coding agent that says, hey, instead of just vibing with me and letting me do whatever you want, you're going to force... it's kind of like a style guide is what I'm hearing around like a coding agent where like you're basically enforcing a style guide that says if you're going to use a coding agent, you must use it with this process. What I find really interesting about this is if I were to apply a style guide is not really about making sure that all code is always beautiful. It's more about making sure that when someone new joins the organization and someone new tries to learn something, there's less questions they have to ask and there's less that they have to figure out.
Yeah, it makes the default thing the correct thing instead of them having to learn how to do the stuff. And it's just the same for coding agents.
Yeah, exactly. I like that principle. I think like if I had to go teach a junior engineer how to go do this stuff, I probably suspect that a junior engineer will get way better consistency by following a robust set of steps versus a how would I describe it? Versus kind of like a versus using like a generic Claude Code. Because generic Claude Code will produce slop unless you know what you're doing. Like on our team, we spend a good amount of time. I think for everything we code gen, we actually spend a lot of time doing building tooling around all the code to actually help us evaluate the code in a really, really good way. And I can show you some of that tooling if you're interested in how we did it. But there's a lot of more things that we end up doing.
Yeah. So I'll show a couple more things, which is like everyone's obsessed with Ralph Wiggum this week. I know we talked about this back in October, but you can also use this to do things like Ralph. So you don't need the bash loop, and you can do these kind of like, you can wrap it in a deterministic harness of like, it's either run once or run forever, but you can do your while true in here. You can, look at you could assign a structured output to this and decide, hey, have we met the exit condition based on what the model actually like outputted?
Yeah.
and then this is just going to run forever. I think we have a Ralph MD that is like you were building. There's no specs in this one because it's just simple. But it's like, yeah, you're building a SaaS platform for burrito delivery. Awesome.
I love burritos.
Right? This is my favorite vibe coding benchmark is how good of a burrito ops SaaS platform can it make? I got this from Ben Swerdlow over at Freestyle.
I think I want to have burritos for lunch today. Anyway, sorry. Back to AI.
Yeah. Back to AI. So cool. We have is Mike, are you still is Mike still on? Mike built a actual like more complete version of this for his team because they wanted to use Ralph and he wanted to build like a structured workflow around it.
Welcome, Mike.
Hey, you guys hear me okay?
There we go. What's up, dude?
It's going not much, man. How are you?
I'm good, man. So good. Mike's a buddy of mine. I think we met at AI Engineer World's Fair in June. Yep. Talked about all things coding agents. He's in all the fun coding agent group chats. And he's constantly pushing the edge of I believe he's the Elixir guy. If you want to do agents in Elixir, Mike is the guy.
The Elixir and OTP, massive agent swarms, and a lot of multi-agent stuff is where I play. So
yeah,
and teaching. I have a whole team of 25 engineers that I'm teaching AI coding to. So
incredible. And so you had an issue where people wanted to mess with Ralph, and you were like, okay, let me give you something a little bit safer than just go YOLO mode in a bash script. Do you want to talk about like why you built that and maybe like share your screen and walk us through the code for 5-10 minutes?
So a couple problems and where I started from that led me down this road. One, I like Ralph Wiggum. I like the idea of teaching that the context window, one, shouldn't be filled up entirely. There's the dumb zone. We don't want to run into a lot of compaction because compaction is lossy and you lose intent. So that's kind of one concept that I've really anchored the team on. The second is the research, planning, and implement flow. And we've done a lot of work with that. We have tailored RPI prompts that in our brownfield code base, which is a 5-year-old TypeScript Firebase code base, there's some stuff in there. There's some dragons. And so the intent was, how do we step out of that? And how do I teach this with some training wheels? So, classic idea springs up. And I wanted to strap a deterministic workflow around Ralph Wiggum. And there's 3 layers. So the top is, I wanted to be able to see the prompts that were generated, the research prompt, the planning prompt. I wanted to see the outputs and put those into our code base. So this is currently, can't show a proprietary code base. This is an open source code base. And I wanted to close that, the previous version of this. Be able to, in each of our features, again, have a customized research prompt. So I did one as an example for this where I wanted to port over, I had an old version of this called my roadmap tool for my open source project, Jito, that used a research MD for every feature I wanted to implement. Think of this as your spec or the research markdown file. I then wanted to translate that into our plan MD. And then from the plan MD, I really liked Ryan Carson's approach of capturing the plan and the research and putting it into a structured prd.json. So here we have, what's the feature ID? What branch are we going to put it on? And then the user stories with the ability to set the state of their doneness as Ralph rolled through this.
And so we talk about like JSON versus Markdown a lot. The idea I'm guessing here is like, because this is going to be read possibly by models, but more importantly by deterministic code, right? Having a status enum like to do in progress done lets non-model code kind of orchestrate these like smaller bits into like the actual agentic parts of the workflow, right?
Correct. And we have 3 sample prompts, and it's kind of fun because let's see, in the implement prompt, we have template tags. So these are our kind of initiating prompts where every time it goes and does a feature, it pulls that structured data.
And then each one of them
this is the prompt that gets pushed into the agent.
Yeah. Makes sense. Yeah,
This is
I think
also,
this is
yeah,
awesome because this is literally what Dexter was describing, but
yeah,
clearly put into practice.
yeah.
So
Yeah, you
I have
spent
a
more
question for
time on
you.
this than I did on my demo.
So I've got a question for you because I
Hmm.
think probably from here people can go see how you implemented this and how they did it, and I suspect they could go build this. But the question for you that I have here is like, what have you noticed as your team has been using this? What trade-offs have come out of this, and what have you lost, and what do you think you've gained?
So it's 24 hours old. We've been doing it by hand. This is the first attempt to formalize the process with this much structure. So one of the things I do as an engineering leader is we're using the AMP agent and Claude Code. And the benefit of AMP is I go and I read and review their threads. And I use
Mm.
that as the primary coaching tool to help them climb the curve on agentic AI engineering and agentic coding. And that is the plan here. That's sort of the intent. That's the idea of what I want to get to, because that coaching loop, that feedback loop is really, really critical to help them
I
learn and
agree.
grow.
I'm Mike. I'm really keen on getting your feedback, perhaps about
Yeah.
like a month from now, on what you learned from this, and having you
Yeah.
back on to come and basically say
Happy
like,
to.
does this work or not? Because I'll tell like I've actually found something very interesting here. When I sat with Dex for the first time and actually did like a proper
Hmm.
RPI workflow with him for 7 hours, my first instinct was I'm gonna go make my whole team go learn this.
Yeah.
And what I really found that was really fascinating was
Yeah.
the more I codified it, the less other people wanted to do it.
Hmm.
And the more Dex codified his way to do it, the less I wanted to do it. I feel like I looked at it and I was like, I like these parts of it, and I really want to do it in my own way. And
We used to joke in the like developer like platform as a
Yeah.
service like world was like everybody wants a platform as a service, but the only requirement is that it has to be built in house. Nobody
Yeah.
wants
yeah,
to use somebody else's pass.
Yeah.
yeah, and it's
Every project I joke it's a baby. You're having a baby and the baby takes care and feeding, and they like having the baby. They don't like taking care of the baby after it's here. And
well, the reason
it's
I'm really
funny to manage it. Yeah.
the reason I'm really particularly curious about these coding agent workflows is because to me, the world hasn't really settled on agile versus Jira. I don't
Yeah.
like the 70 different ways to do task management. Our team, for example, literally uses a Notion checkbox list
Yeah.
over everything else, and it works really well for us. But I know a lot of people swear by linear. A lot of people swear by GitHub issues. A lot of people swear by whatever they do. And even for people that use the same tool, there's no homogeneous way of using it.
Yeah.
Because its process is so arbitrary. I'm really curious if that ends up being true for coding agents, and how true it'd
Yeah.
be. Clearly, not every person manages their own tasks. There's some shared way of managing tasks. But for coding agents, I wonder if it is like it's shared across a person, it's shared across a team, across an org, across industries. And you can clearly see how it might vary.
Yeah.
And I just don't know where it ends up falling. And that's what's really fascinating to me about this world.
That's a really good kind of thing to pay attention to. We've had some variants, but it's a lot of the people that maybe we interact with are further along in that learning journey versus I think the majority of engineers out there are maybe haven't even touched Claude Code, maybe are just back at that. Where were we even 6 months ago of pasting code into the Anthropic website and coding that way, and we've just accelerated far beyond it. There's a vast sort of gulf of people and their learning, and everybody is just trying to hop to that next thing. And so far, I wouldn't say they haven't gone in like parallel tracks in their learning and styles. It's more strung out, and I can, among my team, see who's trying to jump to that next level of learning as they
Yeah.
go. And
Well,
we've focused in on that because we want to get them up the curve, right?
what I would love to do is what we should do is we should take this GitHub repo that's open source and we should link it on the AI that works page and send people over to it. So then
Yeah,
they
that'd
can
be
go
sick.
check it out.
So there is again, I slapped together a CLI tool. This
Wait,
was
can we see
a
it? Can you?
24-hour
Okay.
vibe code. I called it Wreck It for Wreck It Ralph. And there's some information there. I won't go into it, but I just wanted to show this example. So I had an old roadmap again in my open source project, And with a single sentence prompt, it pulled together and wrote an entire Python script to port my old roadmap research and plan MD files into the new Reckitt format. The couple things going on here, just so again, you know where we're going, and this is more very future looking. We have gone towards giant monorepo repositories. So in my open source world, I manage 20 plus Elixir packages that are all set up as Git subtrees in my projects folder. And then we push them back and forth. This has been amazing for
submodules. So you're a fan of submodules.
Not submodules, subtrees. Okay. Yeah, they're different beasts that don't have all the problems of submodules. And then
I was like, if I met a single person who likes Git submodules, I'm like, damn, 2026 is about to get weird. But okay, we'll have to look into subtrees.
Subtrees aren't locked to commits, right? They're like linked to like some.
They
make it easier.
Go take a look. I probably won't do them justice. I immediately wrap them all in handy workspace CLI tools. So I don't even think about it anymore. That's one thing we have going on. The other is there's a new project that is 2 days old. I did a video on this, but it's sprites.dev by Fly.io. Cloud sandboxes, stateful sandboxes. These are, they've cooked with this. Again, this launched maybe 2 or 3 days ago, and we're moving to have multiple sprites managed via API. So part of the thinking with this Ralph CLI is I can dynamically spin up a sprite, give it a feature, off it goes, and a PR shows up and shut down the sprite. And
amazing.
That's where we're going, because I want to run 6 of those at once.
Yeah, and you want to be able to close your laptop and come back to finished code. And so this is awesome. I agree with Vaibhav. It would be awesome to have you. I know this is a day old project. I would love to have you back in like a month or so and find out what you learned and what's working and what changes you had to make. And like, this is what we do is we solve a problem and then we put it in people's hands and then we find out which parts break and then we make it better and then we share our learning. So thank you so much for jumping on and showing this stuff off.
Thanks for having me.
Vaibhav, we got time. I know we're over time. You want to do some questions from the chat?
Let's do some questions if we've got some.
Amazing.
While we're here, I'll show you guys some coding workflows that I have been doing and how we've been moderating it. Well, if you have questions, just feel free to ask.
I will keep an eye on the chat while you're demoing.
One of the first things that we started doing now is actually like building really good visuals around understanding code. So I think one of the first things that I find is when I'm vibe coding, it's actually quite hard to actually understand the control flow, especially in like really complicated projects. So like we clearly have one, and it's a compiler with a bunch of steps. One of the easiest things to happen on your vibe coding is dependencies and abstractions start leaking really poorly. And once that happens, basically you diverge, and then it will only get worse over time. And it's really hard at any point to review the code. So what we do is we just build a little UI that helps us go understand the control flow of code. And now what I can do is I can basically enforce that certain dependencies aren't done. So what we've done on top of that is we've built a bunch of pre-commit hooks. So it's like, for example, we know for sure that no package outside of compiler packages should take dependencies on compiler packages themselves. They should always depend on BAML project. So we can now enforce that with with this, where we build tooling that's like literally CI/CD checking that says, hey, if it's a compiler package, only things that belong to the compiler, the LSP can directly call it, or these specific projects. Everything else gets this compiler error that says, nope, not allowed. And there's really nice ways to build like nice abstractions on top of this that basically prevent leakage. And then also keeping this up to speed does another thing. It actually helps developers understand as your code gets bigger, like exactly what the control flow of code is and understand how stuff should be moving, because we can talk about higher level abstractions along the way. So this is like one tool chain that we've been doing really aggressively. The other tool chain that not a lot of people think about is all these commands, whether it's TypeScript, Python, Rust, Ruby, Java, whatever language you have, are always running these build steps as a part of their scripts. Your build steps add a lot of noise into your context.
Yep.
So every build set that you run needs to run warning free. If you're running with warnings, you will get a lot more context bloat than you are otherwise. So we basically enforce at compiler time that there are literally no warnings allowed at when you check stuff in. And super small things, but these things end up compounding really, really heavily as you build a more complex code base along the way. So just 2 small tips. There's a lot more, but we'll talk about the share later. But like build a visual diagram of your code base, understand dependency graphs, and then on top of that, like build CI/CD tooling to reduce like context bloat.
So do you regenerate this? Because this reminds me of something we talked about with evals, which is like, okay, you can't like deterministically evaluate whether the new version is correct or not, but a human can look at a diff and just like eyeball it in 5 seconds. Like,
so
it's fascinating. Like as part of a PR, if this got generated, and then you could be like, oh, nope, you added a bad dependency. I don't like that, without having to go read all the code.
It's actually even better than that. WC-L. This thing is only 485 lines long. It's an SVG, so you can pass it in either as an image to any agent of your choice, or you can pass it in, and because it's an SVG, it's diffable. So what I actually can do is I can actually like show Claude Code or any coding agent, just look at the diff of the thing, this is wrong. And I have a script to go do this. And it's actually really easy for it to understand. And it's actually really important that this needs to be done as an image, not as an SVG generally, because graph layouts are actually not stable. Anytime you do a graph layout algorithm, like adding one node can truly swap it anyway. So you need an image representation. But we also can't regenerate this on CI/CD for that reason, because it's different in that way. But it is really important that you can go do it from that perspective.
That is really cool. Yeah,
it's a really cool. Useful thing. If you guys are interested in building this, we can probably open source the repo that generates this. It is very useful for me.
Sick. We have one question in the chat, and then I think we should probably call it for the day. Luis says, Dex, how much better was the output of using the SDK approach versus breaking out create plan into 2 separate prompts and write the output of the first prompt as an MD file and then provide that MD file as context to the second step? So this is actually how we did it. We basically have like a version internally of the RPI workflow that's like 5 or 6 steps basically instead of just 3. And so you use like different slides. So we basically like broken up the compaction from, instead of doing like research plan implement, it's like generate the questions and then use the questions to do the research so the research stays objective, and then use the research plus the ticket to create a design discussion doc, and then we create an outline doc, and then we create the actual plan. And like the problem with that is like some people, like it takes a while just to learn, okay, do the research and then do the plan and then I do the implement. And like once you get reps with it, but it's like, what we're going to like tell people now you have to learn 6 slash commands just to do this. And so that's kind of the corollary to this is like, if you can build structured workflows and you can use AI to kind of like make recommendations that understands the workflow itself. Maybe you're not forcing people into the next step, but you're showing them in the UI like, hey, it looks like you're done with design because the questions are empty. Are you ready? And like basically making it so the user doesn't have to think. Like they still have full control and they can iterate as long as they want before moving to the next phase. But in practice, it is basically that you have like 5, 6 slices of the original 3 prompts that get spread out into separate steps based on where are the actual high leverage things for a human to review. The other problem we had is like plans suck to review. They're actually too long. Like we used to use plans as the artifact of mental alignment. We've moved back to actually reviewing the structure outline, which is like the overview of the plan without the actual, like, here's the 250 lines of code we're going to write in this phase. So
do you want to see
to answer your question, else? Like, yes. Yeah, what you got?
Right along with that line. Well, actually, I to chime in what Dex was saying there is like, really, I think what you're asking, Luis, is like, is there a UX that is better than like serializing to disk and moving out and off? And I think what Dexter is saying is yes. He thinks that if we codify the process a little bit more, then we can basically give the user a much better UX. It's basically like saying like, technically we could take all the stuff, paste it directly into Claude Code, paste it directly into ChatGPT or Anthropic and get the result back and bring it back and do the work manually. But the UX of having it with my editor or on my file system directly is just superior. Here,
because you get all the escape hatches. You can go edit the file yourself, and like you can always take a file and feed it through a very simple structured output prompt, right? You take a 500-line design doc, I don't care how long it is, you give that to Haiku, it can tell you if there's open questions in a second.
And then on the other hand, you have like these other class of tasks that you know are super simple. So you're okay kicking off to a background agent where you know you have no interruptibility with it. That's totally fine. But it's more about understanding what you actually want for the kind of workflow that you're doing. What Dexter is talking about is I'm doing a heavy, complex design task. For example, designing, let's say, my entire backend API surface area. I want a UX that is designed to be interactive and makes me think about design decisions. If I just vibe it all the way, I will get the outcome of that, which is a vibed backend, which is good for some use cases, probably not good for if I'm shipping an enterprise reliable API.
Yep.
And I think that's really what the thesis of why Dexter is kind of thinking about how to build structured process in the UX workflows here. Dexter, you made a comment about like you did not enjoy reading plans. I'm about to blow your mind. Ready?
You make a plan visualizer?
We have something new that we've been doing. So we write a lot of design docs as a part of what we do, specifically because we make a lot of language features. And every time you make a language feature, it can be really cumbersome of what you end up doing.
Yeah, if you do it wrong, you have to support it forever because it's a programming language and you can't take it away from people once it's there.
Exactly. On the other hand,
you
this
also
is
better than last time. This is
you also need
you've done work on this.
You also need a lot of feedback from so many other people on the team every time we go design something. So let's take this example. Like for example, we've been implementing how to do exceptions in BAML, and our syntaxes look something like this. If you have opinions, please let us know. But the whole point of what's going on here is we've designed an exception syntax and we have all sorts of rules around this. The thing is, we want to make sure that people can leave comments. So now people can just leave comments right away. But we also want to make sure that this is agentic friendly because most things that live like this are like Notion where you can't use Claude Code or something like that. And that freaking blows. Well, how do we deal with that problem? Well, we deal with this problem by being able to export everything. And it actually exports everything to a folder structure for you automatically with every single historical version and everything else. And then you can use Claude Code to edit all the files. And then all you do is you re-import everything. And it basically creates a new version in a very linear fashion. So it abandons the idea of Git because Git doesn't really matter here. I want checkpoints that are stable and well understood.
You're never merging. You're like rarely merging stuff here.
Yeah, it's because it's not the workflow for like doing like plans kind of workflow. They're more like reviewable. And it lets you have a really nice thing. And then what we have is that we have an AI assistant that actually goes through every single comment that actually happens and verifies whether the comment was addressed or not. That's manually. Sick. So we've actually built this kind of into a workflow because like we still want humans to be able to read this really easily. We also want really easy edits for certain kinds of things if I want. So I don't want to have to think about editing everything manually with AI or having to download it. But I also want the ability to have like long form decisions and like just general like I think where is it like for example like I can see that there are 2 comments here and to see this and Aaron's like, oh, do we actually need a finally keyword? And like we can just discuss this really quickly and have a conversation here without having to think harder about this. And I think having this kind of thing can be like I think this is kind of what you need for editing massive amounts of markdown files. You want something like Claude Code and any coding agent that comes out in the future can edit. And how do you do that? Well, you have a file as a source of truth. But you also want something where humans can collaborate, which means you need some sort of website, you need some sort of sharing system, and you also need some sort of like commenting engine on top of it. That's really nice.
And none of that exists now. We've talked about,
no one's built this yet.
Yeah, like an evidence tab next to a PR or...
Well, it's not even attached to PRs. I actually view this as totally separate.
Okay.
I kind of view this as orthogonal to PRs because it's like design docs. And during the think about like we have survived for decades where our design docs live outside of our code base.
It's true.
And it seems to work. Like it seems to work totally fine. And I actually suspect that's actually okay going forward as well. If our design docs leave outside of our code base, because code evolves much faster than design. Yeah. And that's okay. Designs are actually, design docs don't actually exist to help you establish a code base forever. They're designed to checkpoint your code base at some point in time with the context at that time. And at some later point, you evolve the code with new information. And whether the old design doc still applies or not is totally kind of orthogonal almost. to the actual code, and it's a different decision. And if it does, you often in that case would explicitly choose to have comments and other systems as a part of your code system, not as a part of your design doc.
Yeah, and like the PR phases. I mean, the thing we always talk about is like, how do you move the SDLC upstream, and how do you automate as much of it as possible, while making sure that humans have leverage over the parts that matter, like deciding whether we have a finally statement or not. And like in the past, all like mental alignment for software has either been like design docs and architecture decisions, which are good, and people who are serious and building serious work always do, but they're kind of a pain. Like no one has fun building a design doc. Maybe if you're a PM for a programming language, you do, but like most people have fun writing code. And like we did most of our review and alignment in the PR phase. And so like, yeah, things like this is like one of the most exciting problems right now, is like, as the place where human leverage is most important shifts up to being more about the thinking and the design versus the like coding bits themselves, how do our collaboration workflows change? So this is really exciting. I am stoked that you guys are like figuring out what you want here.
Well, we were doing this with a bunch of Notion files. We were doing this with a bunch of like other stuff, and then we were just like, this is just not doable. And then we literally just spent like 2 weeks. One of our Paulo on our team, who just recently joined, was just like, I'm just going to take this problem on, and he built the whole thing, and it's amazing. It's immediately useful, and I think I've been surprised that no one has really worked on a really good shareable Markdown experience yet.
Not yet. Stay tuned.
Well, yeah. Well, we're going to open source this very soon. This is pretty open source, so it should be accessible by hopefully anyone along the way.
Cool. Well, thank you guys so much. This was a blast. I think the big takeaways were, and help me out here, guys. My biggest takeaway that I would have you all take away from this is like, don't use prompts for control flow. If you know what the workflow is, use control flow for control flow, because it's very, very good. And like, start with something broad and, you know, robust in terms of being able to accept a wide range of inputs. And then when you learn about what the actual inputs look like, refine your workflow and try to have more happy paths available. And then you can still have the escape hatch of go fully agentic. You guys got takeaways?
I would agree. There's a place for what I term classical AI, state machines, behavior trees. These are control flows that have been with us for 30 years. And now we're trying to insert this agentic loop with all this non-determinism, and you need both. They both have a place. We're figuring out what that looks like, but you have to be on the cutting edge, and it's going to be emergent over the next 12 to 18 months. And I'm excited for that.
My big thing is, my takeaway for anyone building any sort of agentic workflow is think heavily about the user's UX. Like if your user's UX is a tight loop, let that be fast, and then kick off background tasks to do heavy duty verification, like what we do here in the UX that I showed you, where we take the new version and we validate that every comment was verified. So the human doesn't have to do the overhead work. They get a message in Slack saying, hey, all comments are taken care of, or hey, you missed these comments. Was that deliberate or not? Design that in your coding agent and decide what needs to be fast versus what needs to be slow. What's synchronous, what's asynchronous, what's a background task. All of these are key design decisions, and you shouldn't just overlook them. And if your coding agent builds an agentic workflow and doesn't ask you those questions, well, maybe consider using the new workflow that Dex is considering, which actually asks you questions along the way and makes it a lot more deliberate when you go do this.
Amazing. Guys, thank you so much. Thanks to
anyone
everyone in the chat.
I saw some people might want to contribute to Markdown Editor. Hop in the Boundary Discord, shout out and contributing. I'll show you where the code is and where that goes. Next week's episode is going to be really fun. We're going to talk about a new coding agent that talks about how to use email as an API and what sort of constraints you have to go build around there. If that's interesting, tune in. Episode should be live already on the Luma for BAML.
Amazing. Thanks, y'all. Have a great day.
Good to see everyone.
Thanks, guys.